Hi everyone, welcome back to my channel. This is Mr. Budehas, your online math teacher. In today's video, you will learn how to calculate the probability of union and intersection of events. Let's start. Let's learn first what is probability of the intersection of two events. It is the probability that both events will occur. It is denoted by P of A intersection B, or the probability of A intersection B. The formula for finding the probability of the intersection of two events is P of A intersection B is equal to the cardinality of A intersection B over the cardinality of the sample space. Cardinality is all about the number of elements in a set. For example, a fair six-sided die is rolled. Find the probability that the outcome is even number and greater than 3. In this example, we are sure that this problem talks about intersection because of the conjunction and. If the conjunction used is and, it is pertaining to intersection. We let A be the event that the outcome is an even number, and we let B be the event that the outcome is greater than 3. We will start from the sample space. Since the experiment is the fair six-sided die, meaning the sample space is from 1 to 6. 1, 2, 3, 4, 5, and 6. Our n of s, or the cardinality of the sample space, is equal to 6 since there are 6 elements in our sample space. Next is for event A, the even number. We have 2, 4, and 6. We cannot include number 8, 10 since that's not part of the sample space. Then for set B, the elements are greater than 3. We have 4, 5, and 6. Those are the numbers that are greater than 3 from 1 to 6. Then, finding the intersection of A and B, or the common elements for set A and set B. We only have 4 and 6 as the common, and finding the cardinality of A intersection B, or the number of elements in A intersection B, which is equal to 2. Now we can use the formula for finding the probability of A intersection B. That is the cardinality of A intersection B over the cardinality of the sample space. Our A intersection B is 2 over n of s is 6. Then, reduce to lowest term, divide both numerator and denominator by 2. So we have 1/3. Therefore, the probability of A intersection B is equal to 1/3. Next is the probability of union of two events. It is the probability that either of these events will occur. It is denoted by the probability of A union B. The formula in finding the probability of A union B is equal to the probability of A plus the probability of B minus the probability of the intersection. We need to subtract the probability of the intersection to avoid calculating the probability of the elements that are common to both sets. For example, a fair six-sided die is rolled. Find the probability that the outcome is either even or a multiple of 3. In our example, the conjunction used is the word or rather. Meaning, this problem is all about union. So we'll be using the formula in finding the probability of the union of two events. We let A be the event that the outcome is an even number, and B be the event that the outcome is a multiple of 3. We will start from the sample space. Again, since the experiment is about the fair six-sided die, our sample space is from 1 to 6. 1, 2, 3, 4, 5, and 6. Then, the cardinality of the sample space is equal to 6 since there are 6 elements. Then, set A is equal to the even numbers from 1 to 6, that is 2, 4, and 6. N of A, or the cardinality of set A, is equal to 3 since there are 3 elements. And for set B, multiples of 3, we have 3 and 6 only. N of B is equal to 2. Then, probability of, we have A intersection B, the common elements there for set A and B is only 6. Our N of A intersection B is equal to 1 only. Okay? Next is finding the probability of A, probability of B, and the probability of A intersection B. For probability of A, the formula is N of A, or the cardinality of set A, over the cardinality of the sample space. Our N of A is 3 over N of S, which is 6. So we have 3 over 6. Then probability of B, that's N of B over N of S, 2 over 6. And probability of A intersection B is equal to N of A intersection B over N of S. That's 1 out of 6. Then we can now use the formula for finding the probability of A union B, which is probability of A plus the probability of B minus the probability of the intersection. Substitute, we have P of A is 3 over 6 plus P of B 2 over 6. Then P of the intersection is 1 out of 6. As we observe, the fractions are similar fractions, so it's easy for us to add and subtract these fractions. Just copy the common denominator, then operate the numerator. 3 plus 2 is equal to 5, minus 1 is 4. So we have 4 over 6. And then reduce this to lowest term, divide both numerator and denominator by 2. So we have 2 over 3, or 2/3. Therefore, probability of A union B is equal to 2/3. Next, we have the mutually exclusive events. These are events that cannot happen at the same time. Two events, A and B, are mutually exclusive if the probability of A intersection B is equal to 0. For example of this is, if we have set A is equal to 1, 3, 5, 7, and 9, the set of odd numbers from 1 to 10, and set B is equal to the set of even numbers from 1 to 10, which is equal to 2, 4, 6, 8, and 10. So if we're going to find the intersection of A and B, there is no intersection since there is no common element. So that is mutually exclusive events. Another example, in a standard deck of cards, drawing a spade and drawing a heart is mutually exclusive since it cannot happen at the same time. There is no card that is a spade and a heart at the same time. Same thing here, you cannot have a number that is odd number at the same time even number. So that's an example of mutually exclusive events. I have here one example only. A fair six-sided die is rolled. Find the probability of rolling either an even or a composite number. So the keyword there is the conjunction or, meaning we will be finding the probability of union of two events, since the conjunction used is or. Take note that the formula for finding the probability of A union B is P of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So we need to have probability of A, probability of B, and the probability of the intersection. Okay, we will first determine the probability of A and probability of B. We will start from the sample space. The sample space is from 1 to 6, since again we are using fair six-sided die. 1, 2, 3, 4, 5, and 6. And n of s is equal to 6, since there are 6 elements. Then for set A, we have the even numbers 2, 4, and 6. So n of A is equal to 3. Then for set B, that is composite numbers. The composite numbers from 1 to 6 is only 4 and 6. N of B is equal to 2. We cannot include the number 2 there, since 2 is a prime number. Now finding the probability of A, that is N of A over N of S. Our N of A is equal to 3. Then the number of cardinality of the sample space is 6. So we have 3 over 6. Then the probability of B, that's N of B over N of S. That is 2 out of 6. Please take note of this, 3 over 6 and 2 over 6. Next is determining the probability of A intersection B. From there, take note again, our set A is 2, 4, 6. And then for set B is equal to 4 and 6, the set of composite number. So our A intersection B there is only the number 6. N of A intersection B is only 1 out of 6. So finding the probability of A intersection B, that is N of A intersection B over N of S. That is only 1 out of 6. Now is finding the probability of A union B. Probability of A union B is equal to probability of A plus the probability of B minus the probability of A intersection B. Our probability of A there, going back, we have 3 over 6 and 2 over 6 for P over B. 3 over 6 plus P of B is 2 over 6 minus the probability of A intersection B is only 1 out of 6. As you observe, the fractions are similar fractions, so it's easy for us to add and subtract these fractions. Just copy the common denominator, then operate the numerators. 3 plus 2 minus 1, and that is equal to 4 over 6. And reduce to lowest term. Divide both numerator and denominator by 2, so we have 2/3. Therefore, the probability of A union B is equal to 2/3.